Good morning, everyone. First of all, I thank IAVM for providing this opportunity to share and spread the knowledge of Vedic math. The topic I have chosen for today's presentation is conversion of rational decimals to fractions by addition and by subtraction. Abstract. Rational numbers are terminating decimals, recurring decimals, or partly recurring decimals. Rational numbers can also be represented by fractions. This paper shows how to convert rational decimals to fractions using by subtraction, by addition, and by observation. Objectives of the paper are converting terminating decimal to fraction by observation, converting recurring decimal to fraction by subtraction and by observation, converting partly recurring decimal to fraction by subtraction and by observation, converting partly recurring decimal to fraction by addition and by observation. Terminating decimals. Terminating decimals are numbers with finite number of digits after the decimal point. For example, 0.34, 4.395. To convert terminating decimals to fractions, write the number along with place value of the last digit. For example, 0.34, place value of 4 is 100th. Write 34 in the numerator, 100 in the denominator. 4.395. Place value of 5 is thousands. 4 is the whole part. Write 395 in the numerator, 1000 in the denominator. Recurring decimals. Recurring decimals are numbers with set of digits recurring infinite number of times after the decimal point. For example, 0.438 recurring, 0.5147 recurring. To convert purely recurring decimals to fractions, we multiply once to shift the decimal point at the end of the pattern and keep the decimal point at the beginning of the pattern. Then using by subtraction, we can convert to fractions. For example, 0.438 recurring. Let's take it as x. To move the decimal point at the end of the pattern, multiply x by 1000. 1000x equal to 438.438 recurring. To keep the decimal point at the beginning of the pattern, multiply x by 1. 1x equal to 0.438 recurring. Now we do subtraction. 1000x minus 1x is 999x. On the right side we get 438. The recurring part becomes 0. X equal to 438 over 999. From this we can understand to convert purely recurring decimals to fractions, write the pattern in the numerator, count number of digits and write as many nines in the denominator. Now we try this with by observation. 0.5147 recurring. Here 4 digits are recurring. Write the pattern in the numerator 5147 over 4 nines in the denominator 9999. Another example 0.142857 recurring. Here 6 digits are recurring. Write the pattern 142857 in the numerator and the denominator becomes 6 nines. 1, 2, 3, 4, 5, 6, which simplified to give 1 over 7. Next is partly recurring decimals. In some decimals, recurring part occurs after few digits. For example, 0.008 recurring, 0.427 recurring, 0.2358 recurring. Here we see how to convert partly recurring decimals to fractions using Vedic sutras by observation, by addition and by subtraction. By splitting. Here recurring digits occur after zeros. Using splitting, we can convert to fractions. For example, 0.05 recurring, 0.00045 recurring. Now we see how to convert to fractions. 0.05 recurring. Split this fraction into two parts, 0.1 times 0.5 recurring. Now convert to fractions. 0.1 is equal to 1 over 10 times 0.5 recurring is 5 over 9. Now we multiply, it becomes 5 over 90. From this we can understand the numerator is the recurring part. Number of 9s in the denominator is equal to number of recurring digits, and zeros in the denominator is equal to number of non-recurring digit. Another example, 0.00045 recurring. Write the pattern in the numerator 4, 5. And number of recurring digits are 2. So write 2 9s in the denominator. And number of non-recurring part is 3 digits. So put 3 zeros. 0.00045 recurring is equal to 45 over 99,000. Another example, 0.00864 recurring. Write the pattern in the numerator. 864 is in the numerator. 3 digits are recurring, so we should write 3 9s in the denominator and 2 non-recurring digits. So put 2 zeros. 0.00864 recurring is equal to 864 over 99,900. Next is by subtraction. For example, 0.427 recurring. Let's take it as x. To shift the decimal point to the end of the pattern, multiply by 1000. 1000x equal to 427.7 recurring. To move the decimal point at the beginning of the pattern, multiply by 100. 100x equal to 42.7 recurring. Now do subtraction. 1000x minus 100x is 900x. 427.7 recurring minus 42.7 recurring is 385. X is 385 over 900. From this we can understand that to get numerator, take the non-recurring part and recurring part and subtract the non-recurring part. For the denominator, number of recurring digit gives number of 9 and number of non-recurring digit gives number of zeros. 427 minus 42 is 385 over 900, and for the simplification we get 77 over 180. 0.427 recurring is equal to 77 over 180. Now we try one more example using this method without doing actual calculation. 0.2358 recurring. Take the non-recurring part and recurring part, subtract the non-recurring part, which is the numerator. 2 digits are recurring, so we put 2 9s, and 2 digits are non-recurring, so put 2 zeros. The answer is 2335 over 9900. And for the simplification we get 467 over 1980. 0.2358 recurring is equal to 467 over 1980. The conversion can also be achieved by using addition. Consider the same example, 0.427 recurring. Split the decimal into non-recurring part and recurring part. 0.42 plus 0.007 recurring. Convert to fraction 42 over 100 plus 7 over 900. Take LCM. 900 is the LCM. 42 times 9 plus 7, which is equal to 385 over 900. From this, we observe that to get the numerator, multiply the non-recurring part by number of 9s and then add to the recurring part. On further simplification, we get 77 over 180. Now try this method with another example. 0.2358 recurring. First we write the denominator. It has two recurring digits, so we should write two nines, and it has two non-recurring digits, so two zeros. Write the non-recurring part, multiply by number of nines, and then add to the recurring part, which gives 2335 over 9900. On further simplification, we get 467 over 1980. By comparing addition and subtraction method, subtraction is more easier than addition. Conversion of partly recurring decimal to fraction is one of the very important topic for secondary students. Here are few questions from IBMO. The first one is converting 0.163 recurring to fraction in lowest form. Now we try with subtraction. Write the non-recurring part and recurring part. Subtract the non-recurring part, which gives the numerator. The denominator is two digits are recurring, so two nines, and one digit is not recurring, put 10. It gives 162 over 990. Just by observation, we know 2 is a common factor. It becomes 81 over 495. 9 is also a common factor. On further simplification, we get 9 over 55. Option A is the correct answer. Another question, 0.327 recurring to fraction. Non-recurring part and recurring part. Take away the non-recurring part. Two digits are recurring, so 99, and one digit is non-recurring, put 10. It becomes 324 over 990. On further simplification, we get 36 over 110. 2 is also a common factor. It becomes 18 over 55. D is the correct option. In few steps, we can easily arrive the answers. As a new learner of Python programming, I have tried this in Python. This is using by addition. This is using by subtraction. Conclusion. This paper showed how Vedic sutras by subtraction, by addition, and by observation are used to convert rational decimals to fractions. This is one of the examples to conclude that Vedic sutras are pillars of mathematics. Here are the references. Before I conclude, I would like to thank my parents who always bless me and my family who always support me. I owe my deepest gratitude to our Guru Sri Bharati Krishna Tritaji, and I am very much thankful to my teacher Professor Kenneth Williams. My special thanks to IABM for providing this wonderful opportunity, and once again I thank you all.